Okay, hi everyone, welcome back to the Comptia Security Plus course. Delivery of malware. Malware is not sentient and not yet and can't just appear out of thin air. It needs to be transported and delivered to a computer or installed on a computer system in some manner. This can be done in several ways. The simplest way would be for attackers to gain physical access to an unprotected computer and perform their malicious work locally, but it can be difficult to obtain physical access. This can be done in other ways as shown in the upcoming sections. Some of these methods can also be used by an attacker to gain access to a computer, make modifications and so on, in addition to delivering the malware. This method that a threat uses to access a target is known as a threat vector. Collectively, the means by which an attacker gains access to a computer in order to deliver malicious software is known as an attack vector. Probably the most common attack vector is via software messaging and media. Malware can be delivered via software in many ways. A person who emails a zipped file might not even know that malware also exists in that file. The recipients of the email will have no idea that the extra malware exists unless they have software that can scan their email attachments for it. Malware could also be delivered via FTP because FTP servers are inherently insecure. It's easier than you might think to upload insidious files and other software. Malware is often found among peer-to-peer P2P networks and BitTorrents. Great care should be taken by users who use these technologies. Malware can also be embedded within and distributed by websites through the use of corrupting code or bad downloads. Malware can even be distributed by advertisements, and of course removable media can victimize a computer as well. Optical discs, USB, flash drives, memory cards and connected devices such as smartphone can easily be manipulated by automatically run malware when they are inserted into computer. This is when autoplay, auto run is not your friend. The removable media could also have hidden viruses or worms and possibly logic bombs discussed later, configured to set that malware off at specific times. Potential attackers also rely on user error. For example, if a user is attempting to access a website but types an incorrect domain name by mistake, that user could be redirected to an altogether unwanted website, possibly malicious in nature. This type of attack is known as typo squatting or URL hijacking. URL stands for Uniform Resource Locator, which is the web address that begins with HTTP or HTTPS. The potential attacker counts on the fact that millions of typos are performed in web browsers every day. These attackers squat on similar but not exact domain names. Once that user is at the new and incorrect site, the system becomes an easy target for spyware and other forms of malware. Some browsers come with built-in security such as anti-phishing tools and the ability to auto-check websites that are entered, but the best way to protect against this is to train users to be careful when typing domain names. Another way to propagate malware is to employ automation and web attack based software kits, also known as exploit kits. Exploit kits are designed to run on web servers and are usually found in the form of PHP scripts. They target client computers, software vulnerabilities that often exist within web browsers. One example of an exploit kit is the Black Hole exploit kit. This is used and purchased by potential attackers to distribute malware to computers that meet particular criteria, while the entire process is logged and documented. Botnets and Zombies. I know what you're thinking. The names of these attacks and delivery methods are getting a bit ridiculous, but bear with me. They make sense and are deadly serious. Allow me to explain malware. Allow me to explain. Malware can be distributed throughout the internet by a group of compromised computers known as a botnet and controlled by a master computer where the attacker resides. The individual compromised computers in the botnet are called zombies. This is because they are unaware of the malware that has been installed on them. This can occur in several ways, including automated distribution of the malware from one zombie computer to another. Now imagine if all the zombie computers had a specific virus or type of attack loaded and a logic bomb defined a bit later was also installed, yet ready to set off malware at a specific time. If they were done to hundreds of thousands of computers, a synchronized attack of great proportions could be enacted or on just about any target. Often this is known as a distributed denial of service or DDoS attack and is usually perpetrated on a particular popular server. Once that serves many requests, if a computer on your network is continually scanning other systems on the network, is communicating with an unknown server and or has hundreds of outbound connections to various websites, chances are the computer is part of a botnet. But botnets can be used for more than just taking down a single target. They can also be used to fraudulently obtain wealth. One example of this type of botnet is the zero access botnet. It is based on Trojan malware that affects various Microsoft operating systems and is used to mine Bitcoin or perpetuate click fraud. It is hidden by many antivirus programs that, through the use of a rootkit infecting the MBR. In 2012, it was estimated that the botnet consisted of up to 10 million computers. You can imagine the sheer power of a botnet such as this and the amount of revenue it can bring in per month. Every couple of months you can read about another botnet mastermind who has been brought to justice only to be replaced by another entrepreneur. Active interception. Active interception normally includes a computer base between the sender and the receiver to capture and possibly modify information. If a person can eavesdrop on your computer's data session, that data can be stolen, modified or exploited in other ways. Examples of this include session theft and man-in-the-middle MTM attacks. Privilege escalation. Privilege escalation is the act of exploiting a bug or design flaw in a software or firmware application to gain access to resources that normally would have been protected from an application or user. This results in a user gaining additional privileges more than were originally intended by the developer of the application. For example, if a regular user gains administrative control, or if a particular user can read another user's email without authorization. Backdoors. Backdoors are used in computer programs to bypass normal authentication and other security mechanisms in place. Originally, backdoors were used by developers as a legitimate way of accessing an application, but soon after they were implemented by attackers who would use backdoors to make changes to operating systems, websites and network devices, or the attacker would create a completely new application that would act as a backdoor. For example, back orifice, which enables a user to control a Windows computer from a remote location, often installed via Trojan horse. This particular one is known as a remote access Trojan, or RAT. As previously mentioned, some worms install backdoors on computers so that remote spammers can send junk email from the infected computers, or so as an attacker can attempt privilege escalation. Unfortunately, there isn't much that can be done about backdoors aside from updating or patching the system infected and keeping on top of updates. However, if network administrators were to find out about a new backdoor, they would inform the manufacturer of the device or the application as soon as possible. Backdoors are less common nowadays because their practice is usually discouraged by software manufacturers and by makers of network devices. Logic bombs. A logic bomb is code that has in some ways been inserted into software. It is meant to initiate one of many types of malicious functions when specific criteria are met. Logic bombs blur the line between malware and malware delivery system. They are indeed unwanted software but are intended to activate viruses, worms or trojans at specific time. Trojans set off on a certain date are also referred to as time bombs. The logic bomb takes away until the correct time, date and other parameters have been met. So some of the worst bombs do not incorporate an explosion whatsoever. The logic bomb could be contained within a virus or loaded separately. Logic bombs are more common in the movies than they are in real life, but they do happen and with grave consequences, but more often than not they are detected before they are set off. If you as a systems administrator suspect that you have found a logic bomb or a portion of code of a logic bomb, you should notify your superior immediately and check your organization's policies to see if you should take any other actions. Actions could include placing network disaster recovery process on standby, notifying the software vendor and closely managing usage of the software, including perhaps withdrawing it from service until the threat is mitigated. Logic bombs are the evil cousin of the Easter egg. Easter eggs historically have been a platonic extra that was added to an OS or application as a sort of joke. Often it was missed by quality control and subsequently released by the manufacturer of the software. An older example of an Easter egg is the capability to force a win in Windows XP Solitaire by pressing Alt-Shift-2 keys simultaneously. Easter eggs are not normally documented, being tossed in at last minute by humorous programmers and are meant to be harmless, but nowadays they are not allowed by responsible software companies and are thoroughly scanned for, because an Easter egg, and who knows what else can possibly slip past quality control. And because of the growing concerns about malware in general, many companies have adopted the idea of trustworthy computing, which is a newer concept that sets the standards for software, for how software is designed, coded and checked for quality control. Sadly, as software goes, Easter egg days have passed. Preventing and troubleshooting malware. Now that we know the types of malware and the ways they can be delivered to a computer, let's talk about how to stop them before they can happen and how to troubleshoot them if they do happen. Unfortunately, given the number of computers you will work on, they will happen. If a system is affected by malware, it might be sluggish and in its response time or display unwanted pop-ups and incorrect home pages, or applications may be even the whole system could lock up or shut down unexpectedly. Often malware uses CPU and memory resources directly or behind the scenes, causing the system to run slower than usual. In general, a technician should look for erratic behavior from the computer as if it had a mind of its own. Let's go over virus and spyware and look at how to prevent them, and finally discuss how to troubleshoot them if they occur. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.